Hey everyone, so as someone who makes stuff online, these are wild times. AI can literally create any image we can dream up. But that brings up a huge question, right? If you make something with AI, how do you prove where it came from? And maybe more importantly, how do we stop people from making fake images that look 100% real? Well, today we're going to dive into some pretty incredible tech that might just be the answer. All it takes is a few words typed into a prompt, and boom, you have a photorealistic image that you'd swear is a real photo. And while that is amazing for creativity, it's also what powers deepfakes and this just flood of synthetic media that makes it so hard to know what's real anymore. This isn't just a technology problem, you guys. It's a trust problem. So this is really the big question. What if every single piece of AI-generated content, every image, every single frame of video came with a hidden, unforgeable birth certificate, a secret digital signature that proves exactly where it came from and that it is, in fact, synthetic? That is the massive idea we're digging into today. To really get our heads around this new digital birth certificate tech, we first have to talk about why the old ways of spotting fakes, well, they just don't cut it anymore. So let's break down the real challenge that companies like Google are trying to tackle here. For a little while there, everyone was talking about AI detectors, these tools that would try to guess if a photo was made by AI. But the research here shows a massive flaw. They're often wrong, and they're pretty easy to fool. So the goal has shifted. It's not about guessing anymore. It's about knowing. Knowing, for sure, the origin, the source, the provenance of an image. And that leads us to this key term, digital provenance. I know, it sounds a little academic, but the idea is actually super simple. It's that digital birth certificate we mentioned. It's not about a tool saying, this looks kind of fake. It's about having a real, verifiable record that says this image was made by this exact AI model on this date, period. And this chart just breaks down that difference perfectly. AI detection on the left, it's basically a guess. It asks, is this AI? And it can totally be wrong. Provenance, on the other hand, is a confirmation. It answers a way more powerful question. Who or what made this? That's a verifiable signature, and for accountability, that is an absolute game changer. So how in the world do you create this digital birth certificate? I mean, you can't just slap a logo on a file. Anyone could remove that. The solution is something that sounds like it's straight out of a spy movie. It's basically a type of invisible ink that gets embedded right into the image itself. And this tech has a name. It's called SynthID, and it was developed by Google DeepMind. Think of it as an invisible watermark, but it's not just sitting on top of the file. No, it's literally woven into the pixels of the image. So to your eyes, the original image and the watermarked one look exactly the same, but to a special scanner, there's a secret message hiding inside. The way it works is actually brilliantly simple. It's a two-step process. First, an encoder adds that invisible mark right after the AI generates the image. Then, down the line, a special decoder tool can scan any image and see if that specific mark is there. Encode and decode. Super simple, but incredibly powerful. Okay, but wait. My creator brain is already firing off questions. I mean, I edit my images all the time. I crop them, I throw filters on them, I compress them to upload them. Surely doing any of that would totally destroy this invisible watermark, right? Well, the researchers definitely thought about that. Yeah, seriously, what happens if you put an Instagram filter on it, or you resize it to make a thumbnail, or heck, even if you just take a screenshot of it? Does that digital birth certificate just go up in smoke? For this whole idea to be useful at all, that mark has got to be incredibly tough. And just look at this list. This is the absolute gauntlet they put SynthID through. We are talking about every single thing we do to images every day, usually without even thinking twice. Saving it as a JPEG, cropping it, changing the brightness, throwing on a filter, even just slapping some text or an emoji on top. For this to work, the watermark has to survive all of it. So, how did it do? Well, this chart from the paper basically tells the whole story. On the y-axis, you see brittleness, which is just a technical way of saying how easily the watermark breaks. Obviously, you want a low score here. And as you can see, SynthID is way less brittle, meaning it is way more tough than the other methods it was tested against. It really holds up under pressure. But look, making a totally unbreakable watermark isn't that simple. In fact, the engineers behind this are facing a really fundamental challenge. It's this kind of constant balancing act where you can't get everything you want all at the same time. The research paper calls this the quality robustness payload trade-off, but I like to think of it as the impossible triangle. You're always trying to balance three different goals that are all pulling in opposite directions. You can't perfect all three at once.
So here are the three corners of that triangle. First, you've got quality. The watermark absolutely has to be invisible, or else it ruins the image. Second, robustness. It has to survive all those edits and attacks we just talked about. And third, payload. It has to carry enough information to actually be useful, like which AI model made it. The really tricky part is, if you make the mark more robust, you might start to see it, which hurts quality. If you try to pack in more data, you might make it easier to break. It is a constant trade-off.
And I love this quote from the researchers themselves because it really sums up the whole philosophy. The goal isn't to create a system that is 100% absolutely, positively impossible to break. The goal is to make it so hard and so expensive for someone to remove or fake the watermark that it's just not worth their time. It's all about raising the cost of being deceptive. Okay, so let's bring this all back home. We've got this powerful new tool for digital provenance. Does this mean the problem of fake content online is solved? Is every single AI image from now on going to have this secret watermark? Well, the answer seems to be a pretty clear not quite. Invisible watermarking is a massive leap forward, for sure. But it's not some magic silver bullet that's going to solve the entire problem all by itself. It's one really important piece of a much bigger puzzle. And here's that bigger picture. SynthID works best when it's part of a whole ecosystem of trust. So you have the invisible watermark, which is like that secret signature hidden in the pixels. But then you also have public stuff like C2PA, which is kind of like a transparent nutrition label you can actually see in the file's info. And you've also got fingerprinting, which is basically a superpowered reverse image search. Altogether, they create layers of defense against fakes. And if you're thinking this is all just some theory for the future, you have to see this number. According to the paper, SynthID has already been used to watermark over 10 billion images and video frames. 10 billion. This isn't science fiction, people. This is happening right now, at a scale that's almost impossible to wrap your head around. So what's the final takeaway here? On the one hand, tech like SynthID could be a huge step towards a more authentic internet, one where we can actually verify what we're looking at. But on the other hand, you have to figure that as the tools to mark content get better, the tools to attack them will get better too. So it leaves us with this fascinating question. Are we at the start of a more truthful web, or are we just at the beginning of a brand new digital arms race? Something to think about. Thanks so much for watching.